So welcome to another episode of Beta Talk, and I'm joined by Leia, Ken, who've been guests on this show before. Leia's from a company called Your Energy, Your Way. Is that right, Leia?
That's right, yep, yeah.
Ken is renewable energy. Have I got that right, Ken?
Renewable heat.
Renewable heat.
Still renewables at the end of the day.
And I'm also joined by Rob. Rob, what's your company called?
Solarflair. I should just pull the shirt into view, shouldn't I?
Well done.
Nice.
So these guys are all engineers, and I just want to give a bit of a shout out today because a guy called Guy Newey did a tweet Sunday, basically saying this is the most important podcast in UK energy. So I just want to say a big thank you, because Guy used to be the special advisor to the energy minister. So since he did that tweet, I had quite a few people from quite high up places follow the podcast. So I'm really grateful for that. And the reason Guy said people should subscribe to it, the reason he said that is because it's listening to people like my guests, the engineers, the ones that are out there doing this sort of stuff, seeing the challenges that we all face with getting renewable technology into, whether it's new builds, whether it's into retrofitting homes. So listening to the engineers that actually deal with this technology day in, day out is actually quite important. So I'm going to come to Ken first. Ken, you've been in this game a long time. You're well regarded. What sort of things have you been seeing over the last 6 months? What's been happening?
Certainly, there's been a major uptake, apart from the COVID, which we had obviously a spell of not doing much work at all, and the leads and the phone calls dropped off. But soon as that started to get back to some sort of normality, we've actually been inundated with inquiries for all types of technologies, actually. But quite a few around solar thermal, which you'd appreciate. Mm-hmm. So, but people are now becoming much more aware of the multi-technologies and how some of them can complement each other, and you can do a complete house or home energy system. So certainly we are getting far more inquiries. General public seem to be much more aware of, as I say, the products out there, the different technologies, the RHI. There does seem to be a bit more information that the public are gaining in that area.
You talked about the RHI. Like, how do you see this RHI scenario panning out?
Well, currently the RHI is a big boon for people who are doing exactly what Ken is talking about and looking at all these technologies, because a lot of our customers are doing kind of whole house retrofits. They've moved into an oldish property and they're kind of having a go at everything that they can, and generally they're replacing the boiler. So if you're already having to replace even a gas boiler, by the time you take the gas boiler replacement cost plus the RHI, you're not actually paying an awful lot more to put a heat pump in. So especially if you were also ripping out radiators and putting new radiators in as part of the refit. So it does feel that for quite a lot of our customers, having that 7 to 10K from the RHI means that gas boiler doesn't need to be renewed, and they can go with a heat pump instead. So it feels to me like that's driving quite a lot of our business. I don't know how Rob feels about that, but don't know what will happen after March 2022 when that goes, and it's just a £4,000 grant is the current proposal. That'll make quite a difference.
Yeah, I want to bring in you, Rob. Now, Rob, you've been in without being rude, you've been in this industry a long time, buddy, haven't you?
Just a little bit, let's say from 1975. Yes, just a while, just a few years.
What are the sort of challenges you see at the moment for homeowners or engineers?
And at this minute in time, I mean, I'm a little out of the water because as you well know, I moved in January and then straight into lockdown. So, I've not literally had a couple of jobs lined up to do up here, and of course they haven't come to fruition yet because I'm still in lockdown as I am at the moment. Looking at the industry as such at the moment, I just think it's education for engineers to shift from gas boilers, because I think the move's got to happen, and the shift has got for the majority of what I call, let's call them boiler fitters. I'm going to be a bit rude, they can curse and do whatever, but I mean, there are boiler fitters that go and throw, as I call, a Velcro install of a gas boiler on the wall and walk away and leave it at that. Now, there's an awful lot out there. Good engineers can see the shift, and they will need to get trained up to do heat pumps. And I think that's where, and there's the education that comes with all of that.
As you know, I always defend the engineer, all these boiler fitters. I mean, you come from an era where
Yes.
perhaps people were getting trained better. We then had this sort of era where gas safe come around, or it was Corgi that basically. And then the first year Corgi started was 1991, and anyone could get on that course, and everyone did, and it's kind of been like that since. And we didn't really train people to be what I would call heating engineers. It was just literally about putting boilers on walls, and we have got problems now. I mean, a lot of the boilers going in, for instance, aren't set up correctly. I mean, I know the manufacturers and the organisations will say they're high efficiency boilers. Well, they are, but you need an efficient system for them to be efficient. And most of them aren't efficient. So we definitely do need to train up these engineers to transition, and that's probably that's my speciality, the training. I'm always kind of at loggerheads with people in my industry because they think we need a paradigm shift basically, and they still think training is you go in, do a 2 days training course, and then you're going to remember what to do. And we see it on the unvented course. So we train people for half a day on unvented cylinders and for water rigs, and someone might not do an unvented cylinder for 3 years. You know, they might be doing bathrooms. And then, of course, they go to a job and they've lost or forgot a lot of that knowledge. And why wouldn't they? Our brains are efficient. We chuck out knowledge that we aren't using. Yeah. So that's a big problem. Training is a big problem. They haven't, I don't think, sussed it yet. And I will try and just keep inculcating what I think they should be doing. We want to talk back to, you mentioned about like changing radiators sometimes. Now, when do you know that you've got to change, this is mainly for a home, or when would you know that you've got to change radiators or parts of the system to accommodate a heat pump?
So generally, when we do an initial site visit, we kind of take measurements of all the radiators. We note down what types of radiators they've got in each room, and just by looking, we can generally get a feel for whether the radiators are going to have to change, and we'll warn the customer then. But then it's only really when we've done a room by room heat loss calculation that we can actually tell if a particular room needs a new radiator. But I mean, if you go around a house and all the radiators are quite small and single panel, then you know, you kind of know you're likely to have to change some. But then on other houses, you'll say to people, oh, you know, we'll see how it goes when we do the calc with the radiators. And actually, because a lot of times radiators are just sized to fit under the window, say, and look right in the room, then often, if you know, they can be big enough. So really, I don't know what the other guys think, but really, my experience, the only way to actually tell is to do the calc and work it out that way.
Heat loss is one of the biggest things. Well, it is the biggest thing. If you know what your heat losses are, then you can size everything, and that's your base mark really to start from.
I mean, if you take really, really old properties, you know, go back into the 70s and the early 80s, where a wet system would be installed, but that would have been prior to maybe double glazing or even cavity wall insulation and 200 mil of itchy scratchy in the loft. So back then, the radiators would have been sized for that property. Then all those insulation components came into play, and then all of a sudden that radiator wet system is now oversized. So you put that same system onto a low temperature system, gas boiler, heat pump, you might actually find, as Leia said, that some might actually work out to be about right. You may have to swap the odd one or two, the bigger room areas, but it's all down to calculation. And I'm afraid with the technologies we are now dealing with today, the calculation is the key. You can't just put a finger in the air and guess anymore. You have to really work your numbers, and it can make a big difference into a good or bad performing system.
I mean, that's one thing with the sort of the gas boiler industry. I mean, I don't know how old you are, Larry, and I'm not going to even mention it, but Ken and Rob and I would all remember the Mears calculator, and we'd do our
Yes.
calculations.
Still got it on the shelf.
Or still got it.
And then
in BTUs.
and then that got lost. No one is doing heat loss calculations, and that's the first thing you've got to do. And I sometimes get a little bit, well, I suppose frustrated is the word. So there's this thing about fabric first. Now, fabric is important. Insulation is important. You know, the second law decrees that heat will find an equilibrium. So it's going to move places. It's going to move from hot to cold. It can't move the other way. So insulation is important. It's important whatever heat source you've got. And there's this myth that if you have a heat pump, you have to go and insulate your property to the nth degree. And you don't. You have to always do the heat loss, because sometimes you might have to and other times you won't. And unless you do that heat loss calculation, you don't know that. And there's plenty of properties that can actually be heated with a heat pump.
Heat pumps are a slower burning medium. So going back to that point, if your heat pump matches the speed that your house is losing heat, then you can heat that house with a heat pump. If your house losing heat is quicker than the heat pump can produce it, then you've got a problem. And that's when you can look in. Obviously, the idea is you try and insulate it as best you can. If you can't, then that's when you start looking into things like hybrid systems, bivalent systems. The heat pump could still work for 70%, 80% of that winter season. But then when it gets really seriously cold and the rate of heat loss is just too quick for the heat pump, you need the backup of an oil or gas boiler or LPG to take up that load. Or
we're looking at high temperature heat pumps.
Yes, which is a game changer now.
Yeah.
But under MCS rules, you're only supposed to be up to 55 degrees in your flow temperature, aren't you? But
well, that's where I think things have got to be looked at, and certain things will have to be changed if we're actually going to do this shift and electrify the country. That's the thing.
Let's talk about MCS. So MCS used to sponsor the second season. I am looking for a third sponsor if anyone's listening. Now, we all know that some great engineers aren't MCS registered. I mean, Ken, you're one of them, aren't you? Ken's one of my favourite engineers, and
I used to be, but no longer.
Now, obviously, we're assured that MCS, well, I know they are, because I speak to Ian Rippon. You know, Ian Rippon's a lovely gentleman, and obviously he's trying to make some changes, make it all better, make it a better system. There's still going to be some complexities, I think. Leia, you are MCS accredited, aren't you? I mean, how do you see all that panning out?
It's interesting. I've thought about this a lot, because I feel like there's a mantra out there that MCS is loads of work. And I think I might be bold enough to disagree, because there is a lot of work out there if you want to do all the paperwork for a heat pump. But actually, quite a lot of it we would still do even without MCS if you're a decent engineer. And as such, I'm sure that Ken and Rob are doing them. So doing your heat loss calculations, doing all your DNO applications, because we're doing a lot of systems now with multiple technologies in the one building, we're now kind of spending half our time at the moment fighting with DNO forms. So, you know, stuff like that, building control, DNO, heat loss calculations, none of those are actually specifically MCS driven. You know, I do agree there are some annoying things about the MCS paperwork when it comes to some of the OTT consumer protection stuff that has to be put in the quote, making the quote hugely ridiculously lengthy so nobody reads it. But my considered view, which I'm going to put my head above the parapet or whatever, is that I don't think that the MCS paperwork is the bulk of our headache. There we go.
Oh, well, I just for the listeners, can you just explain what DNO is?
Yeah, so I think they were meant to be moved to being called DSOs at one point, district network operators or district service operators. So the whole country is divided up into regions according to which electricity company actually provides the electricity to your home. So it's in no way related to who you pay your bill to. It is although actually confusingly, a lot of the companies are also have arms that do provide consumer electricity. And I think it makes it worse for us because we're based in the southeast, just west of London, and we have a mixture of customers who are supplied by UK power networks, and then also some who are supplied by SSE power distribution. So we kind of got to get our head around two sets of processes. And although there's an organization called the ENA, the Energy Networks Association, that's meant to streamline the whole thing and make everyone do the same, we find quite a lot of divergence.
I had the same issue with, I say, the DNOs, and you go certain areas. I was in Oxfordshire, and it was basically Scottish and Southern, the majority of the area. And then you went north to Banbury and you had Western Power, and you're then, well, hang on a minute, who's doing what? And the rules, you know, I wouldn't say the rules, but the way they operated was totally different. And it was sometimes a bit of a headache.
Yeah, I mean, we've just had a ridiculous situation lately where we've installed a ground source heat pump, and the customer's having a total refit of their house, and their power needs were going up massively. So I and the builder both said, well, your 60 amp cutout fuse, it's not gonna cut it anymore. So now the homeowner has to make an application for an upgrade to their cutout fuse. The installer can't do it. So the homeowner went away and did that. At the same time, because the ground source was larger than 32 amps on the phase, I have to do an application to put the ground source heat pump in. So these two applications went off twin tracks, and you know what happens? Because I didn't think of this and didn't tell the homeowner that they must specifically mention the heat pump on their application, these two things are now set in parallel with the DNO. And can I get them to marry up the two applications against the same postcode? Not a chance.
No.
So,
this is a complication because obviously in a diverse population as ours, you know, sometimes filling out an application, a homeowner filling out an application can be quite a traumatic or problematic process, can't it? So that's a complication, isn't it, that we can come across.
I mean, going back to the whole thing about the DNO, what they're worrying is basically it's the companies that are looking after the wires that come to your house and are in the road. And what they're concerned about is you're going to be overloading their system, you know, from your property. You have to calculate your maximum demand. And I done my own little video about it recently and was talking about how everybody used to be on an economy 7 and had 7 or 9 kilowatt showers in the 80s, and everything was fine and nothing broke down. But anyway, so basically if you took a close with 10 houses and they only had a certain size cable running into that close, if everybody had a heat pump, or if a couple of people had a heat pump, chances are it wouldn't make any difference. But if all the houses then had a heat pump, technically that system could be overloaded, or the local substation could be overloaded. And that's what they're concerned about. And there's a lot of fear that, you know, we're going to melt the grid and do various things. But in actual fact, the grid is over-engineered anyway because it's AC. If it was DC would actually be smaller cables. Yeah. AC is actually larger cables. But it's not the cables, it's the little substations and everything else in between that there may be, you know, at the back end of a village. It's the typical setup. You know, you're building a housing estate. Technically, they should, and I'm guessing they do, they put in their own little substation on their housing estate. Or do they just tap into the existing? So, you know, it's things like that. And they're just covering their bases, really, to make sure that...
I have no issue with it in principle, but they really need to streamline the processes. And although there is still the ridiculous anomaly that if you go out and buy a range cooker with a nice induction hob on it, you're probably pulling, I'm no electrician, but I'm pretty sure you're pulling more than a heat pump does.
Indeed.
Like Ken says, I mean, the average electric shower is 9.5 kilowatt. Yeah, and there's big properties I know of that have got electric showers in their en-suites. Yeah. No, you have people waking up at the same time switching all them on. That's a lot of amps you're pulling.
My heat pump's not pulling any more than about 3 kilowatts on max load.
And I think it confuses people because you put in a 12 kilowatt heat pump and people think that means you're drawing 12 kilowatt, but obviously that's the output, not what it generally requires.
Yeah.
That's a good point. Can you just explain that, lad? Because for any listener that's a homeowner, listen, they might not actually understand it. So yeah, 12 kilowatt unit isn't pulling 12 kilowatts because of the COP, isn't it? So do you want to just explain it in you're very good at explaining things in layman's terms from that other thing.
Yeah, that's because I mean, I should have fessed up at the beginning. I'm not actually an engineer, you know, Nathan. I was a software engineer originally, but I've come over. Yeah, thanks. But yeah, if you've got a 12 kilowatt heat pump, that's designed to produce 12 kilowatt at a temperature of generally somewhere around -2 degrees. So that's the way you would take the heat loss calculation, depending on exactly, it's a bit different where Rob's based now, I guess. But down in the southeast, you take the heat loss calculation, you'd say that at -2, this house is going to be losing 12 kilowatts an hour, and then you would find a heat pump that's able to meet that demand, and that would be badged somewhere around a 12 kilowatt heat pump. But because on average you're getting about a 3 times efficiency out of a heat pump, then the unit itself is only drawing from the grid the amps connected with 3 kilowatts rather than the full 12.
What is
Yes, so that is right. So a COP, you put one part of energy in, you get 4 parts of energy out, and that's why heat pumps tend to be or are going to be a big game changer for the country as a whole in their CO2 reductions and everything else. It's not like that in the winter. The COPs do go down in the winter, but they're even in the winter, you might get 2.5 to 3 COP on a good unit and a good designed system. And there's a relationship between the temperature that heat pump is putting out and the air temperature that you're putting in for an air source heat pump. If you're running that heat pump at 70 degrees, the COP is not going to be great. If you're running 35, 40 degrees into your heating system, your COP is going to be at its optimum. And that's what we want. And that's why we're trying to emphasize the facts around low temperature heating systems are the way forward. Underfloor heating, rad systems. Yes, there's a window of settings that you have to match. You know, not every heating system that you try and install can run at 35 degrees. It might be nearer 40 or 45, but that's still good. You're still going to get efficiencies. And this goes back to all the heating calculations, the design, the insulation you're putting into the building. Taking that old oil heating system that was fitted in the 70s with no insulation and no double glazing could now actually be used as a low temperature system, maybe on paper.
Well, I think I've actually proved something, a little experimentation in this property, which I'm now in. I say it was built in the 1820s to 1840s, somewhere around there. Solid stone walls. I've got solid floors in some areas. I've got wooden floors in other areas. I have a massive 50 kilowatt oil fired boiler in here, which is, you know, it's not a castle I've got. It's so oversized. I couldn't believe it when I saw it.
Do 50 rooms in, Rob?
Well, it's ridiculous. I mean, it's honestly ridiculous. And I've got it literally on, you know, bit of experimentation. I've minimized the flow temperature on the boiler because it's literally on off anyway. And I've got it right down the flow temperature. I'm actually getting 35, 40 degrees on my radiators on it now. And I can't, the oil tank's not moving. I was hoping to empty it actually so I could see what it's using, but it hasn't moved for 3 months since I've done that. So it just proves the point. It's a condensing boiler. It's a 50 kilowatt condensing boiler. It's not an old boiler. It's only about 4 years old. It's one of my favourite Worcesters, but I won't say anymore. But there we are.
Now, what burn has that got on it? A yellow?
I think it is. Yes, it is. Yeah. But top firing one, I believe. So I've only looked inside it about twice since I've been here. So I just let it when it works, and it actually kicked in the other morning. I was quite surprised when the temperature dropped a bit low. But yes, it's surprising me, and I thought, well, I'll empty the fuel tank now and see where we get to. But we haven't got that far yet.
We're going to talk about my favourite subject now, because you know I always do. Solar thermal. Anyone getting any? I think Ken, you mentioned some people inquiring about solar thermal.
I've got 3 inquiries currently on my desk for solar thermal combined tech type setups. I, unfortunately, because it's just me, mainly, I don't have a lot of office time, and yeah, be honest, I'm a bit sort of backlogged with getting some estimates and quotes out. But yeah, it's definitely coming back on the scene for me. I advertise it on my company website, blah blah blah. So you know, people may just want a bit of maintenance. That they've had a system for a while, hasn't been touched for maybe 3 or 4 years. I went to one the other day. The Glycol, the system was running. The Glycol was absolutely clear, and I said to the client, "Leave it. There's nothing wrong with this system whatsoever. I'm not even going to do a refract test on it. It looked absolutely fine." And that was about 4 years old. To be honest, that particular system was a heat pump system. The solar thermal was the best part of the whole system. But we won't go there today because I'll be boring you silly.
No Tari Glycol then?
No, it was clear. You could still see the indicator bobbing up and down. It was absolutely lovely to see.
That's quite a surprise. But most of the ones I have been to, I think I've probably had about 4 over, prior to the last 6 months, I had about 4 that are actually reasonably, decent, but the rest are just, they've stagnated to distress levels, let's say.
Yeah, treacle, yeah.
Yes.
This is one of the reasons why solar thermal gets a bit of a bad name, isn't it? And it's become, there's a lot of myths around solar thermal. It doesn't work in winter. Well, yes, it does. For low temp heating, yes, it does. It's actually great for low temp heating systems.
Still hoping to prove that one day when I actually get some kit. But
Rob, your company's called Solarflair. I mean, you've been around this technology for a long time, haven't you?
Yeah.
It grows and it changes. What sort of things are you excited about within the solar thermal?
Well, I'm the integration of using. I mean, I've got my own experimentation that will be going on here. That I will be putting a heat pump system in, massive buffer, as Ken well knows, and feeding that with hopefully probably 60 tube solar thermal as well. So that's all going to be all fed into the buffer basically. So that will be my heat source. That's the idea.
When you say massive, what kind of size of buffer do you think?
At
Ken and I have
least
had this
500
discussion.
litre. What I want, at least 500 litre.
So that's probably the sort of size you're talking about if you want to make the solar thermal gain sensible. Is that?
Not necessarily. It just depends on the system you're trying to heat.
Right.
That's the thing. It's basically because I've got to put a ground mount in. This building is listed, so I can't mount anything on a slate roof. So I've got to put a ground mount in that's hidden away. I've got to dig trenches, bring it all in underground, and then into the property. So things are hidden away.
Yes,
and that's the issue. Yeah.
If you can, Rob, just in sort of kind of simple terms, so like for any sort of homeowner listening to that and thinking, what's that all about? See if you can sort of just describe for our listeners how that's actually going to work, that system.
Well, basically, I'm going to be converting what I've got here. I've run the system on the oil boiler, like I said, at low temperature with low flows. And what I've got, I'm surprised it's worked as well as it has because it's been experimentation. So this is really proving a point that any home could be run at low temperature. And so what I'm looking to do is integrate solar gain, all the solar gain you can get through a conservatory sometimes. And most people, if they know what solar gain, they'll go in their conservatory in the summer and say, oh, it's roasting here, it's too hot. Well, that energy I'm putting in via my solar thermal tubes into the heating system, storing it in basically a big hot water cylinder. So that's storing it, but it's not like a general conventional hot water cylinder that supplies your hot water. It's used as a storage vessel.
Literally like a battery. It's a water.
Exactly.
Yeah, the bigger the buffer, like a battery, the bigger the battery, the more capacity you have to discharge into whatever you're doing. So that's the bigger the buffer you can get, the better.
Exactly.
Because I think from the jobs we see, I guess because we're in the crowded southeast of England, people just do not have the space.
No.
That is the biggest issue, but you can still, even I had the same thing, obviously, like I said, in Oxfordshire, and, I was basically from Reading up to Banbury was my area that I covered, and then west across to Swindon, probably. But, the most homes have an airing cupboard. I won't say every home. I didn't in my house. I had down in the southeast. I had no airing cupboard as such. I literally put everything up into the roof space, so everything went there. So you can always find space in a house. You know, it might not be the most convenient, but you can always find space. And you don't have to have, on a standard 3-bedroom house, you don't have to have massive storage because you don't need it.
Yeah.
Whereas this place I've got now, I'm going to need it.
Yeah.
It's horses for courses.
I mean, I think where we're recommending solar thermal is where people have got really quite small roof spaces. And they might come to us saying, oh, we'd like some solar. And we're like, well, you know, you could stick 2 PV panels up there and, you know, you might get, I don't know, 650 watts worth of power. Or you can put some solar thermal tubes on
that makes sense.
in the same space. And especially if people are doing it for the carbon emissions, the carbon emissions saved with 1 solar thermal panel versus 2 PV panels. I don't know the numbers off the top of my head, but I have done the calcs, and you know, it's a factor of 1 to 5. It's that kind of difference, even if you're just using it for hot water.
Exactly the scenario. That's, again, you know, I would say a lot of people used to come to me and say, oh, we want PV on the property. And I'd go there and of course, we'd have windows, Veluxes in the roof or whatever. And, you know, it became, you couldn't economically say, well, it's worth putting PV on there. But you could turn around and say, well, yes, we could put a 20 tube panel up there and that would do your hot water. So that was more cost effective, you know.
Well, I'm going to bring it to an end there. We're going to have a part 2 with these same guests, and I'm sure we'll be talking about the same the challenges that engineers face currently, and sort of we'll sort of touch more on what we're hoping to see in the future. So I'd like to thank my guests, Leia, Ken and Rob, and we'll see each other for part 2. Thank you very much.
Thank you.
Thank you.
Thanks.